Hello again, grade 7s. In today's lesson, we are going to begin the last unit of study in Math 7, that unit dealing with solving equations. And I'd probably say this is one of the most important units in grade 7 math because as we go through the unit, we're going to start to develop some algebraic skills, which has a huge application to a lot of other science concepts. Learning outcomes are to 1, explain the difference between an expression and an equation, and 2, demonstrate an understanding of preservation of equality by modeling preservation of equality concretely, pictorially, and symbolically. We're going to start off by distinguishing between an expression and an equation. And so far in the course, I've been kind of using the two words interchangeably, but it turns out that an expression and an equation are not quite the same thing. Okay, a mathematical expression, and this is how we defined it back in the patterns and expressions unit of study. An expression is a mathematical statement with a combination of variables, constants, and operators. The key thing about an expression is that it does not have an equal sign in it. So a few examples of an expression would be 3x plus 1 or 4 plus 6x. Both of those expressions do not have an equal sign in it, so they do fit the classification of an expression. An equation, on the other hand, we'll give a bit of a wordy definition first, then I'll kind of identify like the easiest way to distinguish the two. An equation is a mathematical statement with two expressions that have the same value or are equal to each other. Okay, so really what we're looking for in an equation is look at the first four letters that spell out equation, EQUA. An equation has an equal sign in it. For example, circumference is equal to pi times diameter. That has an equal sign in it, so we do refer to it as a mathematical equation. Here's another example of a mathematical equation. You have 3x plus 4 is equal to 1 plus 6x. Again, we have the equal sign, which means it's an equation. The other way we define it, though, is we said it's a mathematical statement with two expressions that are equal to each other. So, I mean, look right here, 3x plus 4, that's one expression. We could call that E1 or maybe EX1 for expression 1. And then 1 plus 6x, that's another expression. So we could call that EX2 for expression 2. So if we have two expressions that are equal to each other, that is also a mathematical equation. Okay, so let's do an example. It says, given the phrase 4 times a number minus 5 equals 7, I want to A, represent the phrase as an equation, B, identify all variables, constants, and numerical coefficients, C, I want to model the equation using cups and counters, and D, I want to illustrate the equation using another modeling technique, another way of modeling, this time dealing with algebra tiles. For algebra tiles, we use a green rectangle to represent the numerical coefficient. We use a red square to represent a positive constant, and we use a white square to represent a negative constant. Okay, now we're not going to color code these. I mean, I don't expect people to pull out felts or pencil crayons and they're showing mathematical work. So a green rectangle, what I would do is I just draw a rectangle. Hopefully you can make it a bit more straight than that. A rectangle, and usually inside the rectangle, you identify the variable you're dealing with that's attached to the numerical coefficient. So we'll just say x. X is like kind of like our standard mathematical variable. A positive constant is a red square. So a red square, instead of drawing it red, just draw a square with the letter R inside. And a white square, we just draw a square and then write the letter W inside. Okay, but let's go to part A first. So part A is I want to represent the phrase 4 times a number minus 5 equals 7 with an equation. Okay, the first problem with this statement is it says 4 times a number. Well, what number? I don't know what the number is. It could be any number. So if it could be any number, we need to represent that as a variable. So I'm going to say let x equal, we'll call it the unknown number. Okay, now let's try to write the equation. Okay, so 4 times an unknown number is x. Okay, so 4 times a number would be 4 times x, minus 5 would be equal to 7. Okay, so 4 times an unknown number minus 5 equals 7. Now, we don't need to show the multiplication operator between the numerical coefficient and the variable, so we can just combine it. So then we have 4x minus 5 would be equal to 7. Okay, so that's the answer to part A. 4x minus 5 equals 7. Okay, part B, it says identify all variables, constants, numerical coefficients. Okay, we'll do it based on this equation. So the letter is the variable, so that's v. Now, is the 4 attached to the x through multiplication, numerical coefficient, or a constant? It's a numerical coefficient. A numerical coefficient is attached to a variable through either multiplication or division. How about this 5, numerical coefficient or constant? Well, it's separated by the variable through subtraction. So if it's separated through addition or subtraction, it's a constant. And the 7 is all by itself on the right-hand side of that equal sign. So again, it has no real connection to the variable, so we're also going to call that a constant. Okay, C wants me to, so let's rewrite the equation again. So it's 4x minus 5 is equal to 7. C wants me to represent this with cups and counters. Okay, so the way we do this with cups and counters is your numerical coefficient is going to be the number of cups. And in this situation, that's equal to 4. And then your constant, well, you actually have a couple of them. You have 5 and you have 7. And we use the counters to represent that. Okay, so let's represent 4x with 4 cups. So that'd be 1, 2, 3, 4. And then we can show the subtraction operator. Okay, we're subtracting 5, which is a constant. So we have 1, 2, 3, 4, 5. And then that's equal to 7. So you have 1, 2, 3, 4, 5, 6, 7. Okay, so 4x, 4 cups, minus 5 counters is equal to 7 counters. So that's what the cups and counters. Okay, now D is represent this with algebra tiles. Now for algebra tiles, the numerical coefficient is going to represent the number of green rectangles you draw. So instead of drawing cups here, we're going to draw rectangles. So we'll do 1 rectangle, label it as X, 2, label it as X, 3, show the variable inside, label it as X, and then we have 4 of these rectangles with the variable labeled inside. So that's 4 X's, okay? Now, the next one is minus 5. Now, for cups and counters, we can actually directly show the operator, whether it's like a plus or minus. For algebra tiles, we actually want to classify this 5 as being a positive or a negative constant. So this negative in front of here would make it negative 5, so that's a negative constant. And a negative constant we represent with white squares. So negative 5 would be 5 white squares. We have 1, 2, 3, 4, 5, and that's equal to, so on the right-hand side, it's 7. So that's implied to be positive 7. So positive constant would be red squares. Therefore, this would then be 1, 2, 3, 4, 5, 6, 7. Just ignore that horizontal line that appeared. Okay, so 4x minus 5 is equal to 7. Done at the algebra tiles. Okay, 2, we're given the algebra tiles, and what it wants us to do is write the two expressions that make up the equation and also write down the equation. Now, let's just do the equation. If you write down the equation, we can actually see the two expressions. So we'll just do the equation first. Okay, so 2 green rectangles means you have a numerical coefficient of 2, and a numerical coefficient is always attached to a variable, so you have an x beside it. So 2 green rectangles will be 2x. 3 white squares. White squares are a negative constant, so this would be 2x minus 3. And then red squares would be a positive constant. So positive constant would be 4. 2x minus 3 equals 4. Maybe one way to like memorize whether it's white square or red squares, I think of like red as being like the color of lava, which is super hot and would easily have a positive temperature in degrees Celsius, as where white could be snow. And snow would have a temperature that is less than 0 degrees Celsius, so it'd be negative. Now, in terms of the two expressions, now we can do part A. The two expressions are just the two different parts of the equation. So if you look at this here, 2x minus 3, that is one expression. I'll call that expression number 1. And then the 4 would just be another expression. I mean, it's just a constant, but it's still an expression. Number 2. And that's what an equation is. It's two expressions that are set equal to each other. All right, that's it for this lesson. You can complete pages 393, 394, numbers 7 through 11. I just made a note here for numbers 7 and 8. It's actually going to tell you to write two expressions and then the equation. So what I said is just worry about writing the equation. If you write the equation down, then you automatically will have the two expressions, one on each side of the equal sign. And I will talk to you in the next lesson.